Can still call 911.
Yeah, you press button.
Truth.
1 plus.
Okay, so anyways,
3.
here we go. We're going to do 11-7, probably in a couple parts, so hang on for the ride. This will be probably a 2-day lecture. It's okay. You guys have been graphing, haven't you? You've graphed curves, you've graphed exponential functions. So you have now. You are going to graph quadratic functions, okay? And this is 11.7. Graphing quadratic functions when they're in this format. F of x is equal to ax squared plus c, which means ax squared plus c, it's actually missing the b part, which is fine that it's missing the b part. That's what we're just going to start with, is functions that are missing the b part. Okay, so in any type of quadratic, quadratics will form what we call parabolas. Has anybody heard of a parabola?
Yes.
Parabolas. And the parabolas either open up like this, and that's what the graph, and if they open up, they have a minimum value, and then if they open down like this, then they have a, not a minimum, but they would have a maximum, okay? So if it opens down, it's got a maximum. If it opens up, it's got a minimum, okay? On any parabola, every single parabola is going to have a vertical line. It actually isn't graphed, but we can show it with just a dotted line. There is a vertical line that cuts the parabola in half. And that vertical line that cuts it in half is called the axis of. When something can be cut in half and look the same on either side, it's called
Reflection.
not a reflection, but mirroring.
Symmetry.
Symmetry. Symmetrical. Yeah. So if it's symmetrical, right, it's the same on the one side as the other, then when it's cut in half, this is called our axis of symmetry. Now, the axis of symmetry, I'm going to write a little equation for it. It's x equals negative b over 2a. We may not use that for 11.7, but we're going to reference it because we may get it around to using it, and at least we see it over and over. So there's a little equation that allows us to find the vertical line. Now the vertical line is actually not technically graphed when you go to graph the parabola, but you could see, oh yeah, it's the part that cuts the graph in half. Now, where you have a minimum and where you have a maximum, you will have a coordinate point. That coordinate point where you have a minimum and where you have a maximum, the coordinate point is called the vertex. So the vertex would be just an x comma y that is at the maximum or minimum. Okay. Now there's all these points along a parabola, but to figure out where the minimum or the maximum is, you would have what we call the vertex. Okay. So other things that we need to know is, and I'm just checking, since some of the stuff I have is, okay, they do talk about that, that's good. So there's the general idea. Now, we're going to talk about opening up or down. If a is greater than 0, now you say a, okay, what letter, the letter a, but where are we referring that back to? The
Number before the x.
number before the squared term, yeah. If a is greater than 0, meaning if a is positive, then your parabola opens up, okay? If a is greater than 0, your parabola opens up. If a is less than 0, your parabola opens down. So if you have a negative, it opens down. If you have a positive, it opens up. You recall, maybe you recall this, you don't need to write this down, but y equals square root of x, do you remember? That is a radical equation. Where did it start? 0, 0, and then what did it do? It went like that, right? Then we said, well, what happens when we have a negative out front? Which way did they go? Down. Yeah, so it's the same idea, is that if it's a positive, it's opening, if you will, up above, and if it's negative, it's going down. Same idea. So here, if a is negative, it's opening down like that. Now, oh, they do talk about this. This is good. Now, if a, oh, maybe let's state this. And we'll do some examples with this, it'll help. But if a is actually they do this. Let me show you this. They go absolute value is less than 1. Now you have to go back into your recesses of your brain and be like, okay, absolute value of something less than 1. Do you remember changing absolute value into something other than absolute value and with an inequality? And I don't know if you remember this or not, but we would say A is less than 1, A is greater than -1, meaning if this is some sort of fraction, like an example, would be 1/3, -2/5, -9/11. If A is a fraction between 1 and -1, it makes our graph, I'll go like this, graph widens, okay? So your parabola, would look something like that. If A is a fraction between 1 and -1. Now, if it goes over 1, and it's like, let's say it's 5/3, that's greater than 1. It is a fraction, but it's greater than 1. That's going to narrow your graph. So if absolute value of A is greater than 1, which means, little review of absolute values and inequalities, or this, meaning it could be a fraction, but it's greater than 1 or less than -1, your graph narrows, okay? Narrows. And this seems like a lot, but once we do some examples, I'm putting it on an XY plane for now, right there. So your graph is going to get skinny, right? Narrows. Okay. So that's the general idea of this parabola. Now, we have, if you will, let's start with this. I'm just going to say graph, and we're going to say f of x is equal to x squared. So we look at that, with practice, you're going to look, oh, it's squared, therefore it's forming not a line. It's not forming, remember I just showed you this one, right? That's a radical equation. It's not an exponential equation, 5 to the x. We actually have done those before, haven't we? 5 to the x, and you have these equations that look like this, if you recall those. You're like, okay, x squared, it's going to form a parabola. Okay, now, in this parabola, the question is, where will the vertex lie? The question is, does it open up, does it open down? So if we look at this, we can look and we can do an XYT chart. The most basic way to graph a parabola is XYT chart. The book is actually going to have you do a couple things like this. They're going to say, hey, find f of -2, f of -1, f of 0, f of 1. Maybe they may not ask you to find all of these, but they may ask you to find some f of whatever. Now remember, function notation is, all it is an XYT chart, right? You're plugging in for x, outputting for y. We just don't see y on there. But if it's like mentally, like, what is it? It's really just saying y equals x squared, and they're asking you, plug in a -2 for x, what do you get back out? So we can do some mental math, right? If you plug in a -2 squared, what does a -2 squared give you? 4. What does a -1 squared give you? 1. What is 0 squared? 0. What is 1 squared? 1. What is 2 squared? 4. What we just created is an XYT chart. You don't have to write this, but to make a note of it, -2, 4, -1, 1, 0, 0, 1, 1, 2, and 4. We just created an XYT chart is all we did.
Because there's no parentheses, is the number, why is it turning positive?
Well, it's because whatever x is, that gets squared.
Oh.
So there is a parentheses when you if you were to write it out. Because if we did this and you said, well, is it -2? If you did it this way, that's a great point. You're saying, well, I'm only squaring the 2 and then multiplying by a negative. But remember, we're saying whatever x is. So if x is -2, technically it's like that.
Okay.
Yep. Which is different than I'll show you the other one that we're going to do with a negative involved. So, okay. So they may ask you simply, they might even ask you, there's some problems that just say, find f of this, f of this, f of this. So we know how to plug in. We're plugging in for x and then squaring it, right? And so we know how to work with functions, hopefully. What we did is we created coordinate points, right? We just created coordinate points. So if we were to graph these, we would say, okay, -2 up 4, -1 up 1, 0, 0, 1, 1, and then, 2, 4 like this. So we just created a parabola. Now a parabola is not an absolute value graph where it makes a V. If you remember those, and you know, you've learned a ton of stuff this year. If you recall, like y equals absolute value of x, and we made this sharp V like that, that is not a parabola. That is a line connected to a line. A parabola is some sort of curve. And so when you go to graph these, you don't want to graph a line. You'll be marked wrong. You want to make some sort of curve. Now, it may not be perfect, and you know, but that would be a great little, you know, I'm a little bit off. I missed a little dot there. But, you know, something within reason like this. There you go. That parabola is your base parabola. Y equals x squared. You memorize that. When you see y equals x squared, you know it's a parabola whose vertex is at 0, 0, and it opens up. There you go. That is your base parabola. Parabolas will shift off of that. They're going to shift up, down. They're going to get wide. They're going to get narrow. Left, right, whatever. So this is your base parabola. You just memorize. Okay, 0, 0 is the base, and it goes from there. Now, if I were to ask you, because some of the things that we will talk about, or I think they talk about, is they will say something, where is our vertex? Now, our vertex is where it bottoms out or maxes out. In this case, does it bottom out or max out? Bottoms out, right? It hits the bottom. Now, it goes up forever, so it's got this infinite max, but it bottoms out right here. So where is the vertex? The vertex is where it bottoms out. What would the coordinate point be? 0, 0, right? 0, 0. Now you don't actually have to worry about the vertex equation. You could take negative b, which is 0, over 2 times 1. So it'd be 0 over 2, which would be 0. But you can just visually look at it and say it comes down and it bounces back up. Okay, so the vertex is 0, 0. Does it have a minimum or does it have a maximum? It'll ask you something like that. This has a minimum, right? It's got a minimum. Now it'll also ask, making sure that I just cover these bases. They actually don't ask you for the axis of symmetry, but I'm just going to tell you the AOS stands for axis of symmetry. The axis of symmetry, we don't write it, but it's the, we can just, I put it dotted because technically it's not seen on the graph. That's the vertical line that goes right through the vertex. The axis of symmetry is always the x value related to the vertex. You remember x equals is a vertical or horizontal line. What's x equals? Vertical line. Y equals is a horizontal. So much review, right? So AOS, the axis of symmetry, is always the x value of the vertex. So there you go. And you know, so they may or may not ask you for that, but they'll ask for the vertex, they'll ask for a minimum. Now, in this case, this is your standard graph. Y equals x squared. If we transition slightly away from that, I'm just checking to make sure. Oh, by the way, does it open up or does it open down? They'll ask you that question as well. What does it do? Opens up, right? So it opens up. They'll ask that question, opens up. So you're going to say, oh yeah, it opens up, the vertex is 0, 0, the minimum value, it has a minimum, and then I'm adding in, what's the AOS? The AOS is the x value of the vertex, your axis of symmetry, okay? So now let's do this one. F of x is equal to, let's go with 1/2 x squared. Okay, so all I did was I slightly changed. What did I change? I got the a value turned into 1/2. So when the a value is 1/2, what is that going to do to the graph? We have to come back all the way back over here with all this like discussion. For starters, is a positive? What is a? I just told you a is 1/2. So a is positive, so does it open up or does it open down? It opens up. So right away I could state some things. It opens up. If it opens up, does it have a minimum or a maximum? If it opens up, it'll have a minimum, okay? Opens up and it's got a minimum. Now, something we don't, we'll graph this one and see what the vertex is. The book will also ask comparison of shape. Okay, so on the comparison of the shape, what they're asking is comparing it to, this is your original function. Okay, so in comparison to this, okay, what you would have is, see, they do a vertical. No, let's graph this one, and then we'll talk about what they're going to compare. So if I go to graph this, how do we, the most basic way to graph it is just to do an XYT chart. I only put this up there just so we can test our function notation look, But if we were to do an XYT chart for this, let's plug in a -2 again, and -2 squared, as Nicole pointed out, should turn into a positive, even though we don't see a parentheses. So what's a -2 squared? 4, right? 4 times a half is 2. Plug in a -1. -1 squared is 1. 1 times a half is a half. Plug in 0, you output 0. Plug in 1, you output a 1/2. Plug in 2, you output a 2. Right? Because 2 squared is 4. 4 times a half is 2. So what we see here is 1, 2, 3, 4, 1, 2, 3, 4, whatever. We said -2, 2, -1, 1/2, 0, 0, 1/2, 2, 2. What happened to our graph as we go to connect the dots? And that kind of looks like a V, but what happened to the graph? It did what? It widens. Now, the book actually, so if we were to compare this to our other one, which was the other graph would, look like this, something, that may be a little steep, but, the other original y equals x squared graph would look like that. So what they say they're going to ask in comparison, I say it widens it, because that's easy to think about. They're going to say, does it shrink it or stretch it vertically, is what they're going to have on there. And there's like a nice little chart in your book that kind of talks about that. Meaning, shrinking vertically would make the graph flatter. So it's like, if you think about it, what used to be -2, 4 got shrunk, and now it's -2, 2. Well, it used to be -1, 1 got shrunk to -1, 1/2. So they will ask for, does it open up? Is there, there's a minimum. They will ask for the vertex. What's the vertex on this one? On the blue, I'm looking at the blue. What's the vertex? 0, 0. And then they're asked, in comparison to the x squared graph, what does it do? I have stated it widens it, okay? They are going to say it shrinks it vertically.
Wait,
Okay?
so widen and shrink?
Why did it?
No, what, if you say widen and the book says shrink?
Oh, so right, so the book says shrink vertically, and I'm saying the graph widens.
Okay.
So I should make a definitive, what do I want for us? Is it a vertical shrink, or can we just say widens versus narrows? I think I'm okay. I think I'm okay just saying the graph widens. So the book won't say widens, it'll say shrinks vertically. So I'm okay with, if we want to say it widens or it narrows. Now remember, we're basing this off of what? Off of this is the baseline graph for all parabolas. X squared goes up, we've got it, we visually see it, there it is. So based off of that graph, does the graph go wide or does it go narrow, or is it the same? Okay, so that's what we're going to base all of this off of, is that original x squared graph. Now let's do one more, and again we will revisit all of this tomorrow. We'll do a bunch more examples tomorrow, so it's a 2-day deal. if I said graph this one, also we're going to ask the same types of questions. So let's start with, does it open up or does it open down? Opens down. And you know that just from memorizing that if the a value is less than 0, meaning if the a value is negative, it opens which way? Down. Okay? So we know our graph opens down. Based off of the original x squared graph, sorry, I should write, okay, it opens down. Let me retract. Is there a minimum or a maximum? If it opens down, it's going to have a maximum. Okay? What would you guess the vertex is on this? 0, 0. Yeah, we can take a stab at it. We can check it when we do an XY chart. Now, so it's the graph that opens down. Do you think it's wider, narrower, or the same as our original graph? Now it's opening down, so it's going to look different, but is it wider or narrower? Or the same? Same. Because the -1 just says, hey, we're flipping it down, but it's a 1. It's not a fraction, and it's not greater than 1 or less than 1. It's just -1. So it opens down. So it's actually going to be the same width. So there's no shrinking, there's no widening, no narrowing. All right, so then in which case, if you were to do an XYT chart, this is like where Nicole was asking that question. If you were to plug in a -2 now, remember the -2 goes in for the x. So if you will, it would be stating a -2 being squared, but what's out in front of the x? A negative is out in front of the x. So the -2 gets squared, making it a +4, but then this negative makes it a -4. And then a -1 squared is 1, but then we got a negative out front, so then it would be a -1. And then you plug in 0, you get out 0. You plug in a +1, you get out -1. A +2, you get out -4. So we recognize that this one is just a mirrored graph. Sorry, my marker's dying here, but it's a mirrored graph going just down. So exact same graph as x squared, except it opens which way? Down. Okay? So depending on where you're at with 11.6, that'll be due tomorrow. But if you're all done with that and you want to start tapping into 11.7, this will get you started. And then we'll do a bunch more examples tomorrow. Not about a bunch, but a few of them tomorrow to make sure you're set on graphing. If you want to use graph paper, that's great. If you want to just sketch graphs, that's fine as well. Questions? Okay. We have just a minute left. If you want to grab more sustenance, you can